Okay, so some people are not convinced 100% that evolution exists because some people doubt what evolution is because some people don't really know, again, like not making fun of people, but some people just don't realize what evolution really looks like in reality compared to, like, let's say, like you look at like some other animals, for example, and why they might look different, but how can they be related to humans? Like, for example, some people would always make the uh, the the comparison that why are humans much different than, let's say, like a gorilla, orangutan, or a baboon, and the idea is actually very simple. You see, everything is made of energy. Energy consists of DNA and RNA and all these other, pretty much an infinite amount of and different possibilities of building principles. We call it the building blocks of life, cells or elements and stuff like that. But let's just focus on DNA though. You know, so when every animal has the ability to reproduce. Some animals, well, even bacteria, have the ability to reproduce asexually, or they just divide. Cells have the ability to what is known as mitosis, where they split in half, and it might seem like boring science, but, it's interesting to a lot of people, though. And over time, eventually what we have is what is called heredity. Heredity. Yeah. Heredity. We pass down simple genetics to, certain other individuals, and then, and then their offsprings too, and therefore, like, every time you reproduce, there's a small chance, like, there's a really small change over time, but eventually it turns, like, like, years later, we're talking like hundreds of thousands, there's eventually a difference. You'll start to see a difference. And even time goes by that even, the living organisms from the time they're born to the time they die, they're even slowly changing. Like, for example, aging could be like a way of evolution, sort of. It's like different types of evolution, but we're talking about appearance as an evolution, though. So when you think about, like, why are humans different than, like, other animals, well, the reason why that is because, you have a different classification, what is known as a subspecies. I was explaining this to one of my friends about a few months ago. He was kind of confused. He said, well, why is it that they say that humans are the same, but, all these other animals are different? And the idea is actually very simple. Because, animals, for example, you could say humans are, 97% DNA related to, like, apes, gorillas, and orangutans, and all these other ones, but they look different. Why is that? Because there is enough, even in that 3% of difference, there is enough physical evidence to prove that we are different and in similarities at the same time. For example, humans have the ability to walk on two legs, we have two arms, we have thumbs, and other animals, mammals, have the same thing, same features. Gorillas can walk on 2 feet, they might use their arms too, and there's even, they might live outside and they might have similar features. Who's to say our ancestors weren't? They might have looked more like gorillas than they did now, but the idea is that humans have evolved to the point where, we're different and some things still haven't changed over the time, and science proves that. So, when you have, like, different types of so what you're trying to do is you're comparing two different species, but, like, they still fall into a major portion of the same animal kingdom. So, like, for example, animals, I'll give you another example. Look at all the different types of fish, like for example, like sharks, to dolphins, to whales, to manatees, to pretty much just to name a few. But like, and then, like, look at, like, similar fish like pike, walleye, sheephead, bass, carp. You could also look at, like, bluegills. You could look at perch. they all look different, but they all share something similar. They live in the water, they have gills, they fall into the same category. But what I'm trying to say is this, if you're a scientist, and believe me, if you know what a dichotomous key is, something that people use to figure out something else, how to identify like trees. So they say like if the tree has this, go to this page and it will tell you like over and over again like what kind of tree it is. Dichotomous keys work very well with the animal kingdoms because if you're trying to identify like a new species, for example, then if you haven't already discovered it, first of all, it kind of goes like this. First of all, you have to figure out what animal kingdom that the individual falls under. Then you got to figure out if the species is known to exist, and if you identify the species correctly, what kind of animal is it? And if it hasn't been discovered yet, then it's a new individual. Same thing with humans. We are mammals, we are monkeys, and then therefore we are our own group, Homo sapiens. So over time, if you were to take that into consideration, we are able to say that we're different, but at the same time the same because of similar genetics. And that same idea applies to like fish and fungus and other animals. It's a simple genetic offspring that results in different results, but over time, some things still stay the same. And whether people believe it or not, you'll notice that with other animals, because like you could look at all these other animals at the zoo and say, well, they're all different, but at the same time though, they're strikingly similar in their own ways.